Hi everyone, welcome back to our channel. So today we are going to practically verify ABCD parameters, which is also called transmission line parameters. So till now we know the theoretical calculations of ABCD parameter. Now let us try to practically verify the ABCD parameters. So coming to the circuit diagram, so this is the circuit diagram of ABCD parameters for an T network. Now let us try to see the branches. So we have a series branch of 820 ohm and next series branch of 2 kilo ohm and shunt branch of 510 ohm. So this is nothing but that network. So this is 820 ohm, this is 510 ohm as well as this is 2 kilo ohm resistor, and this is an T network given to us. So here while finding the ABCD parameters, so first one we have to make I2 is equal to 0. So what is I2 equal to 0 means output port is open circuited, and we have to write down the values of V1, V2, I1. Now we will try to do it. So how to give the connections is, you see here, through an RPS connect the ammeter, and at the output you have to make it open, automatically voltage will be available. Now let us try to demonstrate it. So now I am giving the primary connections. So from the positive terminal of the RPS connect to the positive terminal of the board, and you see here now we need to connect to the ammeter. Okay, therefore the positive terminal of the ammeter, let us try to connect to the positive terminal of the ammeter, and ammeter output to the board. This is the board input, this is the ammeter output, we have to connect, and the negative terminal of the board you connect to the negative. Okay, so this is how to give the connections, just very simple. So output of the RPS, this is the output of the RPS output to ammeter input, output of ammeter to board input, and this is directly neutral. So this how we have given the input, and you can see here output is open circuited. Whenever it is open circuited, here you can see here the current, here it is 0. So when you see in the diagram, you can see here the current is 0, I2 is open circuited, 0 into 2 kilo ohm. So 0 into 2 means this will act like an short circuit. So indirectly, if you connect the voltmeter at this point or at this point, both are same. Why? Because voltage is 0. That also I will demonstrate for your concept. Okay. So now let us try to see here. So now this is the circuit diagram. Now let's try to connect the voltmeter also. So from the positive terminal of the supply, you connect to the positive terminal of the voltmeter, and from negative terminal of the voltmeter you connect to the negative also. Okay, so now this is the complete circuit diagram for the given ABCD T type of network. Now let us try to give the supply. As soon as you give the supply, so initially I have been done the previous experiment. Initially you have to keep the current all the knobs to minimum and keep only the current knob in maximum, and slowly you excite the input port. So as soon as you start exciting, it will show the voltage which is nothing but 30 volts. So input is V1, this is nothing but I1, so this is nothing but V2. Okay, so now we have to write down. So input voltage is that 29 volts. Okay, so approximately we will keep it as 30 volts is V1, and input current is I1. So 20, 21, 22, 23. Okay, so this I2 is how much? 23 milliamperes, and at output side this is nothing but the V2. So here the V2, here you can see here what is the voltage indicated, 9.5. So approximately it is 9 10. Okay, 10 amperes. Okay, so write down that given 10 amperes. This is theoretical value, and we have written the practical 30, 22 and 10 amperes, approximately 11 you got, just you can write down as a 10 also. So how to calculate? I2 is 0. Now you can see here I2 we are making as 0, then V1 by V2, V1 30 divided by V2 10, 30 by 10 you are going to get 3. Voltage by voltage, there is no units for A. And coming to the C value, I1, the value of I1 is how much? 22 milliamperes divided by V2 is how much? 10. Therefore we are going to get 2.2. So the units of I by V is mhos. Okay, so 2.2 mhos. That's how to identify. I have been told that whenever you connect the voltmeter, what is the voltage you are getting here? Approximately you can see here the voltage you are getting as 9.5, 10. So, but when you connect here, I already told this is short circuited. The meaning of short circuit is this one. So, here current is 0, 0 into R is also short circuit, therefore voltage is 0. So, if you connect here, the voltage is 0. If you connect the positive and negative here, the voltage is 9 volts. Similarly, since it is short circuited, if you connect here and here also, the voltage remains same. There is no change of voltage from the experimentation setup. This is how to understand the concept of short circuit. Okay, so now coming to the second circuit diagram. In the second circuit diagram, so we have to make V2 equal to 0. I mean, output port has to be short circuited through an ammeter. Now we had made it open circuited. Same, we have to apply V1, I1 rather than making it open circuit and make it as an short circuit through an ammeter. Okay, so now before doing this, I will remove the supply and I will remove the voltmeter. Okay, so now voltmeter is removed. After removing the voltmeter, short circuit it through an ammeter. Okay, so now we are going to make it short circuited. Okay, so actually short circuit, the meaning of short circuit is, so we have to short circuit to positive and negative. When you short, this is the meaning of short circuit. When you short circuit it, actually voltage is 0 and maximum current will flow at output port, but to measure that current we are connecting the ammeter. Okay, so now I am connecting the positive terminal of the ammeter to here. Why? Because current is entering this port, that's why it is positive, and it is going to leave, and that's why it is negative. So this is the connection diagram. Same connection diagram, just through an RPS connect the ammeter in series and just connect to the negative, and just connect an ammeter which is nothing but short circuit, just give the supply. Already we had set the value, so therefore the input voltage is 30 volts. So input voltage is 30 volts. This is V1, this is I1, that is I2. Just write down those values. So you can see the tabular column. When output port is short circuited, when you short circuit, automatically V2 is equal to 0. Whenever V2 is equal to 0, then we are going to get V1, I1 as well as I2. V1 is how much? 30. So practical value is 30 and I1. So I1 value is approximately 24 milliamperes. Okay, so this is nothing but 24 milliamperes, and we are short circuited. Short circuited means current will be flowing. The current is how much now? 5 milliamperes. So write down the current as 5 milliamperes. So now as soon as you make V2 equal to 0, so now V2 is equal to 0, then we are going to get the value of B is equal to V1 divided by I2, and the value of D is equal to I1 divided by I2. So V by I, V1 is how much? 30, I2 is how much? 5 milliamperes. Then you are going to get resultantly in terms of kilo ohms. B will be in terms of kilo ohms. I1 by I2. I1 is 24 milliamperes divided by I2 is 5 milliampere. 5 will get cancelled and will be expressed. There is no units. Just remember, A and D has no units. Why? Because A is V1 by V2 voltage, I mean reverse voltage gain. D is I1 by I2, which is also an voltage gain, but B has ohms, and D has mhos. This is the practical setup of measuring the ABCD parameters of a given two-port network and how to measure the values. Hope you are able to understand the practical setup of measuring ABCD parameters. The next experiment we will continue with H parameters of an two-port network. The theoretical calculation will leave in the card. You can see the theoretical calculation, how to calculate all these parameters in an upcoming video. Thank you for watching the video. We will meet in the another video. Thank you for your help and support. If you are watching the channel for the first time, go to YouTube, just search kvthulasi. You can find my channel and you can view all the remaining contents. Thank you for watching. We'll meet in the another video.